Life is man's most precious treasure. He would do anything to stay alive, but age and time, that old enemy of man, eventually edges him forward to death. There are myriad myths from time immemorial of man's attempts to make himself immortal, but it wasn't all confined to myths. Man's made real attempts using any science or technology he could get his hands on to defy mortality. And with major medical breakthroughs over the past few decades, humans have become closer than ever to making that dream come true. Stem cells, which basically means special types of cells in the body that can divide in order to form other types of cells that have particular qualities or purposes. With stem cells, man's been able to find cures for diseases that were once considered incurable. Every year, millions of people come down with deadly diseases such as blood cancer, and the only way to cure most of them is stem cell transplants. Iran is among the few other countries which have been able to use this science to remedy incurable illnesses. According to a joint study by Harvard University and the Massachusetts Institute of Technology, Iranian scientists have moved to the forefront in embryonic stem cell research. And just recently, Iranian scientists have launched the first stem cell data bank, putting Iran in the fold of the very few countries that possess this sophisticated technology. The data bank contains the information of healthy volunteers willing to donate blood-generating stem cells to save the lives of people with chronic diseases such as pernicious anemia. In this Iran Today, we'll be examining Iran's stem cell data bank and the Iranian medical community's advances in this life-giving technology. Although the recent medical breakthroughs have helped extend the life of terminally ill patients, they've had a long list of dangerous side effects such as heart complications caused by a heart attack, damage to the nervous system, and diseases affecting the bones and joints. In such diseases, the affected area loses part of its functionality for various reasons such as age, vein incidence, diet, and environmental and genetic factors. Unfortunately, despite extensive research over the past decades, a cure for these diseases eludes discovery. Nasser Aqdami is the director of Iran's Royan Institute for Reproductive Biomedicine, Stem Cell Biology and Technology.
توی پزشکی که ما الان داریم و پزشکی است که بر اساس در واقع دارو
We use medicine to stop a patient's condition from getting worse or progressing. But when a patient loses an organ or a tissue, we can't help regenerate or restore the tissue mass with medicine.
از دست داده باشه نمیتونیم با دارو اون رو جبران کنیم یا در واقع اون نقطه رو براش ترمیم کنیم.
People suffering from such diseases have only a few treatment options, using medication over a long period, organ transplant, and the use of specially designed high-tech medical equipment. Dr. Leila Arab is a researcher with the Royan Institute.
لازم بود که به غیر از درمان‌های دارویی و درمان‌های جراحی که در حال حاضر وجود داره
Medicine and surgery can only go so far. We needed even more sophisticated science to help our patients. We're very excited about stem cell research because regenerative medicine could be the key to treating degenerative diseases. It helps the body repair the damaged organ or the tissue. It does that by utilizing stem cells.
انجام میده. شاید در حوزه این علم بتونیم بگیم که کلید اصلی در واقع استفاده از سلول‌های بنیادی یا stem cell هستش.
Regenerative medicine, which is the process of replacing or regenerating human cells, tissues, or organs to restore or establish normal function, was officially introduced as a branch of medical science. This field holds the promise of regenerating damaged tissues and organs in the body by replacing damaged tissue and or by stimulating the body's own repair mechanisms to heal previously irreparable tissues or organs. Regenerative medicine also empowers scientists to grow tissues and organs in the laboratory and safely implant them when the body cannot heal itself. Importantly, regenerative medicine has the potential to solve the problem of the shortage of organs available for donation compared to the number of patients that require life-saving organ transplantation, as well as solve the problem of organ transplant rejection, since the organ cells will match that of the patient.
ابزارهای مختلفی براش وجود داره. یکی از ابزارها میتونه اجزای ریزی باشه که بافت‌ها رو تشکیل داده، مثل سلول‌ها.
There are different instruments for this. One is the body's own building blocks, the cells. Thank God now, with stem cell therapy, using cells to treat diseases has gone to a whole new level, especially in medicine. Stem cells can either divide or turn into other cells. That is why it's such a great tool for creating a specific kind of tissue, identical to the tissue the patient has lost.
سلول‌ها از بین رفته. اینجا سلول بنیادی میتونه یک سلول خیلی خوبی باشه که هم بتونیم زیادش کنیم و هم ببریم اونجا در واقع به انواع سلول‌ها تبدیلش کنیم.
After birth, cell division or differentiation stops altogether, so that the cells in every tissue can only divide and produce more of their own type. Yet there are cells in adult bodies that maintain their ability to divide and differentiate into other cell types. They are stem cells. Scientists try as much as possible to use the patient's own stem cells to replenish the lost tissue, but at times that's not possible, so the scientists will have to use someone else's stem cells.
سلول‌های بنیادی رو میتونیم در مراحل مختلف زندگی یک فرد یا یک حیوان تهیه بکنیم.
We can take cells from a person or animal in different stages of their life. We can extract them while they are still an embryo from the various tissues of that embryo. We can also get stem cells when a living creature is born, and even after it's born. Like the stem cells in the umbilical cord blood. At the time of birth, these stem cells can be taken and saved and later used. But we can get stem cells from a person already born or an adult as well, called adult stem cell. We believe all the body's organs have stem cells, but our focus is on this special kind of stem cells which are found in bone marrow.
But there are safety issues with the latter way. The biggest problem is that the recipient's immune system attacks the intruders, and so the result is what's referred to in the medical world as transplant rejection. The more the overall genetic relationship between the donor and recipient, the higher the chances of a successful transplant. The best case scenario is when members of the same family are involved, but the problem is that more than 70% of those who need a stem cell transplant do not have an eligible donor in their families. Therefore, the only alternative is harvesting stem cells from a genetically matched non-family member. In order to find such donors, you need a special data bank that keeps every person's genetic information that's obtained from a blood test. Given the importance of such a database, the researchers at the Hematology Oncology Research Center and Stem Cell Transplantation at Tehran's Shariati Hospital embarked on establishing a data bank named the Iranian Stem Cell Donor Program. We sat down with the director of the TUMS, Dr. Amir Ali Hamidiyeh.
This was a huge and complicated program conducted by Shariati Hospital. Shariati Hospital is presided over by Tehran University's medical wing and is where all hematology, oncology, and stem cell research is done. Under the supervision of the head of the research center, Mr. Ghavamzadeh et al., and with the support of the university's board of governors, Iran began its first HLA registry program. It is the first HLA registry program in the Middle East, from Morocco to Pakistan as well. So the Iranian Stem Cell Donor Program has been launched for the first time in the region.
ISCDP, Iranian Stem Cell Donor Program.
In March 2007, TUMS became a member of the Bone Marrow Donors Worldwide, a project for the collection of data on volunteer stem cell donors and cord blood units, and responsible for the coordination of their worldwide distribution. Dr. Hamidia tells us more than 3,400 volunteers have registered at the TUMS to donate stem cells when needed, but he said despite the enthusiasm, only those that meet the bank's criteria will be taken on.
کلی افرادی که بین 18 تا 60 سال سنشونه سابقه در واقع سرطان خودشون قبلا نداشته باشن سابقه بیماری قلبی شدید آسم شدید
People between the ages of 18 and 35 who do not have a history of cancer, serious heart problem, asthma, or other immune diseases can volunteer for our HLA registry program. They can fill in a form online first, become a volunteer for the data bank, and later they can visit the Shariati hospital, give a blood sample, after which all their HLA details are recorded and kept in private in the database. When a patient comes in, a search is done in the database to find a match for them. When a match is found, we invite the donor to come and donate his stem cells to be used for a transplant.
اون وقت ما از اون دهنده خواهش میکنیم اگه علاقمند بودن و اجازه دادن میان و ما از سلول بنیادیشون برای پیوند استفاده میکنیم.
We decided to check out TUMS's website at www.iscdp.org. We found the process of collecting HLA phenotypes explained in 5 languages. All you have to do is register online and then go to the research center for HLA typing. The purpose is to find potential donors of stem cells to patients who so desperately need them. The first hematopoietic cell transplant in humans, Iranian scientists were able to do it, was 22 years ago. The operation was successfully done in 1990 by Professor Ardeshir Ghavamzadeh on a blood cancer patient who is still alive. With Iran's population of 75 million, between 1,000 and 1,500 need such transplants every year. It would cost between $30,000 and $40,000 to import one stem cell sample from another country, and $500,000 if the operation were to be done abroad, a fact that makes the Iranian stem cell donor program all the more important. And with the 3,500 transplants that have already taken place in Iran, more than $1.5 billion have been saved.
از 200 کشور دنیا پیوند فقط توی 40-45
Stem cell transplants are being done in only around 40 to 45 countries worldwide. Iran is one of the countries that has this technology, but under 30 countries have HLA registry program. In the next 4 years, another 100 countries may acquire the technology for a stem cell transplant, but at the moment, under 30 can do HLA registry program, maybe 28 countries. As I said, in the east of the Mediterranean and the Middle East, Iran is the only country that has this technology and has been approved by the BMDW.
و خاورمیانه تنها کشوری که HLA رجیستری داره که مورد تایید BMDW هم قرار گرفت.
The Children's Stem Cell Transplant Section at Shariati Hospital set a world record in 2011 by carrying out 110 successful operations compared to an American counterpart that had done 89 operations. More than 60 diseases that used to be considered incurable can now be cured. Stem cell transplants are most effective in curing blood diseases such as blood cancer and pernicious anemia. We asked Dr. Hamidia to name some other diseases that hematopoietic stem cells can now cure.
یک بیماری خونی بدخیم مثل لوسیمیای خون، اکوت لوکمیا، دسته دوم در واقع بیماری نقص ایمنی مادری آزادی یا
Those with chronic blood diseases like acute leukemia, or those born with a disease, primary immunodeficiency, or those suffering from inborn errors of metabolism, solid tumors, or blood diseases that are non-malignant but must be treated with a stem cell transplant, like thalassemia major. The only way to cure these patients is to replace their abnormal cells with the donor's healthy cells.
فرد گیرنده در واقع سلول‌های معیوبی رو داره که باید این سلول‌ها از بین برن و سلول‌های سالم از یک فرد سالم جایگزین اونا بشن.
Stem cell transplants aren't limited to blood-generating cells. Rather, they can help treat diseases ranging from the cornea to the skin.
We prioritize between the various diseases, which ones are more prevalent and more degenerative. At the moment, we're working on heart problems, diseases that affect the skin, bones, and cartilage, and diseases that affect the digestive system, especially those concerning the liver, the inferior and superior mesenteric vein. We're using stem cell research to treat burns like burnt corneas and nerve degeneration.
عصبی جزو بیماری‌هایی هستند که در حال حاضر به نوعی با سلول درمانی داریم درمانشون می‌کنیم.
Iran owes most of its recent successes in stem cell technology to Royan Institute. Established in Tehran in 1991, Royan Institute started out as a research institute for reproductive biomedicine and infertility treatments, and later expanded into 3 research institutes, each focused on different fields of research: stem cell biology and technology, reproductive biomedicine, and animal biotechnology. Royan employs around 200 researchers who have published 18 books and 600 scientific articles around the world. It's also churned out 67 PhDs and patented 26 inventions. For more on this, we talked to the Institute's Deputy Head of Research and Education.
پژوهشگاه رویان بعد از تجربه‌ای که در بحث ناباروری داشت و موفق شد، مجوز مرکز تحقیقاتی رو از شورای گسترش وزارت
The Health Ministry authorized the Royan Institute to take on research projects because of its experience in infertility treatment and later made other research institutes. This coincided with the emergence of stem cell research projects in other countries. The research the Royan Institute had already done on human embryos was a valuable resource for stem cell research. This got Iran onto the list of countries that were active in the field. Extracting stem cells, reproducing them, and freezing them was a new chapter in the Institute's activities.
با تولید و تکثیر و انجماد این سلول‌های بنیادی خب یک فصل و فضای جدیدی روی محققین این مرکز باز شد.
The scientists at the Cell Therapy Center of Royan Institute are running experiments to find cure for more incurable diseases and say some of their studies will soon be applicable.
امروزه بسیاری از تحقیقات ما تو بحث سلول‌های بنیادی
Most our researches are done in the lab. Animal testing is conducted humanely, of course. Some of our activities have become routine procedures, like treating skin disorders and burnt corneas.
بیماری‌های پوستی، مشکلاتی که سوختگی‌های قرنیه و چشم هست.
One of the successful teams at the Cell Therapy Center is the one working on diseases of the bones and joints. Mr. Baghban is a member of that team and works in the Adult Stem Cell Research Lab.
از مواردی که ما مقالش هم پابلیش کردیم استفاده از این سلول‌ها در درمان آرتروز بوده و روش به کارگیریمون هم یک روش خیلی ساده‌ای بوده.
One of the cases which we have published an article on it is how arthritis can be cured by using stem cells. It's a simple procedure which involves injecting stem cells into joint space. We have treated 6 patients with chronic arthritis this way. Their knee joints were their most sensitive joints. Walking was very painful and difficult for them. The X-rays showed the surface of their joints was uneven instead of being smooth. We took mesenchymal stem cells from their bone marrow and injected them into the joints. 12 months later, the patients were finding it easier to walk and they had less pain. The MRI images also showed and confirmed that the stem cells could partly regenerate the cartilage and get the surface of the joints smooth and even. This is just one of the success stories of regenerative medicine.
سلول‌هامون تونستن تا حدودی بافت به اصطلاح سطح ناصاف قضروف رو صاف بکنن و یه بافت ترمیمی رو درست بکنن.
Another team at the CTC is trying to find treatment for diseases affecting the nervous system with the help of stem cells.
ما الان در واقع روی جداسازی کشت و بانکینگ سلول‌های
At the moment, we are doing research on extracting, culturing, and banking of neural stem cells. We haven't got the point where we can bank these cells and offer them to patients yet. We still need to do more research on how to separate these cells. We may need to alter our protocols and spend more time on the separation stage without any problem to bank and offer these stem cells.
مشکلی انجام بشه و بعد ما اینها رو به صورت یک بانک ذخیره بکنیم و بتونیم اهداش بکنیم.
Also at the CTC, the hematopoietic stem cells team. We sat down with its leader.
در کل پژوهشکده سلول‌های بنیادی با توجه به نوع کارکردی که ارائه داده در جوامع بین‌المللی از جمله 10 گروه
In view of the activities our stem cell research center has done, it's now one of the world's top 10. In the Middle East, we've become one of the most successful in blood stem cell procedures, extracting stem cells from embryos. We are now one of the top 3 countries in the region. As far as stem cell research for cancer treatment is concerned, we are on a par with developed nations.
از منابع جنینی سلول‌های بنیادی جنینی اقدام می‌کنیم.
For Iran, stem cell research along with nano, nuclear and aerospace technologies are top research priorities. Official figures show Iran's invested a staggering $1.2 billion in the development of stem cell research. Iran's leader, Ayatollah Sayyid Ali Khamenei, embraced stem cell research and has highlighted the importance of Iran's acquiring the technology.
Nowadays, biotech breakthroughs, especially the stem cell technology, are very important among the nations in the world. And Iran has made great successes in this field. The necessary infrastructure and facilities exist in the country to achieve more in stem cell technology in the future.
The ability to grow human ESCs has opened the door to a generation of new remedies that might be used to treat those suffering from degenerative disorders which are currently incurable, such as Alzheimer's, Parkinson's, diabetes, heart diseases, and spinal cord injuries. But despite this, stem cell research has been overshadowed by ethical controversy and debates worldwide. Religious groups are at the forefront of these debates. As far as Islam is concerned, human life begins when the soul enters the developing embryo, which occurs between 40 and 120 days after conception, so stem cell research is permitted by Islamic scholars. Consequently, ever since the field came into being, Iranian scientists have gone at it full tilt, and the government has supported them. And it seems their efforts have been successful, rendering Iran a frontrunner in the field.